Ever notice how pushing a door near the handle is easier than near the hinges? Or why a long wrench loosens bolts better? That's torque in action. Torque is the force that makes things rotate around a pivot. When you push a door, you're creating torque, the turning force that gets things spinning. Scientists call it the moment of force or simply torque. The formula is simple. Torque equals force times distance from the pivot. The farther from the pivot you push, the less force you need. That's why pushing a door at the handle is easier than near the hinges. The same principle explains why seesaws balance. Heavier friends sit closer to the center, lighter friends farther out. When their torques are equal, the seesaw balances perfectly. This is physics at play, from playgrounds to toolboxes. Next time you open a door or play on a seesaw, remember, you're using torque. It's the secret behind every spin, swing, and turn. What happens when things don't turn? That's equilibrium, a perfect balance of forces and torques. A book on a table isn't moving because gravity pulls down and the table pushes up with equal force. That's translational equilibrium. But there's also rotational equilibrium, like a balanced seesaw, where turning forces cancel out. For true equilibrium, both translational and rotational forces must be balanced. Tightrope walkers are masters of equilibrium, constantly adjusting to keep both types of balance. They match the upward force from the rope to their weight and use their arms or a pole to balance torques. This keeps them steady and upright. Equilibrium is why buildings stand tall and pictures hang straight. It's not just stillness, it's perfect balance in action. Whenever you see something at rest, it's quietly balancing all the forces around it. That's the beauty of equilibrium. Sometimes, two forces work together to create rotation without moving the object's position. This is called a couple. Think of turning a steering wheel. One hand pushes up, the other pulls down. The wheel spins but doesn't move sideways. Couples create pure rotation, no translation. You use couples when opening a bottle or turning a key. For complete equilibrium, two rules must be met. The sum of all forces must be zero, and the sum of all torques must be zero. Imagine a tug of war with equal teams. The rope stays still because forces are balanced. Similarly, a balanced beam has equal clockwise and anti-clockwise torques. Only when both conditions are met does an object stay perfectly still. That's how we achieve unshakable equilibrium. It's the secret to stability everywhere. Let's explore the principle of moments, a key rule for balance. For rotational equilibrium, the sum of clockwise moments must equal the sum of anti-clockwise moments. On a seesaw, a heavier friend sits closer to the pivot, a lighter friend farther away. Their moments balance force times distance on each side is equal. For example, a 40 kilograms child 2 meters from the pivot creates an 80 unit moment. An 80 kilograms friend needs to sit 1 meter away to balance. This principle is used in engineering. Cranes, bridges, and balconies all rely on it for stability. By calculating moments, we predict and control how things turn, or keep them from turning. The principle of moments brings order and safety to our world. It's a simple equation with powerful results. Next time you balance something, you're using this principle. That's the magic of physics in action. How do we know the principle of moments works? We test it. Take a meter scale, balance it at the center, and hang weights at different points. Place a 100g weight 30 centimeters from the pivot. It tips the scale. To balance, place a 200g weight 15 centimeters on the other side. Now both moments are equal. 100g x 30 centimeters equals sign 200g x 15 centimeters. The scale balances perfectly, proving the principle. Try different weights and distances. The result is always the same. Clockwise and anti-clockwise moments match. This experiment shows the power of torque and equilibrium. From doors to skyscrapers, these rules keep our world stable. Science isn't just theory, it's everywhere, keeping things balanced. Next time you see something steady, remember, it's all about torque and moments. That's the wonder of physics at work.